So let's look at the integrating factor method for solving differential equations. So if you have an equation in the format of dy over dx plus a function multiplied by y, and this function is of x, p of x, and it's equal to another function q of x, usually these type of equations are not separable, so you can't solve for y very easily. So that's why we use the integrating factor, which is I of x is equal to e to the integral of p of x dx. So the integrating factor is just e to the integral of this function here, which is multiplied by y. And let's do some examples to see how this works. Okay, so the first question we have is solve this equation where we have dy over dx plus 4y is equal to 12. So this here is going to be our integrating factor because this is our p of x. So our p of x is equal to 4 and our q of x is equal to 12, but we don't need to worry about that right now. So our integrating factor, I of x, is equal to e to the integral of 4 dx, which is equal to, now the integral of 4 is just 4x, so e to the 4x. Now this is our integrating factor, and now what we have to do with this is multiply this factor by all terms in the equation. So all we have to do is just multiply by e to the 4x, and now we're going to get, let's go over here, actually just write it over here, so e to the 4x dy over dx plus 4y e to the 4x equals 12 e to the 4x. And now, let's go up here. In the left side, what we can recognize here is that this is actually the derivative of y multiplied by the integrating factor, which is e to the 4x. That's what usually is going to happen. After you multiply the entire function by the integrating factor, the left side is most of the time y multiplied by the integrating factor. And now, since we didn't change the right side of the equation, this is still just going to be 12 e to the 4x. And now to get rid of this derivative, all we have to do is find the integral, because that's just the opposite of the derivative. So if we take the integral of a derivative, we're just going to get the original function. So y equals, or y e to the 4x. And now if we take the integral of this is just going to be 12 times 1 over 4, so 3 e to the 4x. Now we just have to divide by e to the, and this is plus c. And now we divide by e to the 4x, e to the 4x. Now we get y is equal to, these e to the 4x will cancel out, so 3 plus c e to the negative 4x. And this is our final answer. Question 2, we have solve the equation dy over dx minus 3y is equal to e to the x, where we have the points 0, 2. So they gave us the points because they want us to find the particular solution. So when we have c, we're not going to have that unknown constant because we have a point to go off of. So once again, our p of x is equal to negative 3, and our I of x, our integrating factor, is just going to be e to the integral of negative 3 dx. And the integral of negative 3 is just e to the negative 3x. Now we multiply the entire function by e to the negative 3x. So e to the negative 3x. And then this is just going to be e to the negative 3x dy over dx minus 3y e to the negative 3x. And then the right side is just going to be e to the negative 3x times e to x is just e to the negative 2x. And then now, this whole left side is I'll just write it here, the derivative of y times e to the negative 3x, which is the integrating factor. And the right side stays the same, so e to the negative 2x. And now we have to integrate both sides, so dx and dx. Now this left side is going to be y e to the negative 3x is equal to, the integral of e to the negative 2x is just negative 1 over 2 e to the negative 2x plus c, and then we divide by e to the negative 3x on both sides to solve for y, equal negative 1 over 2 e to the x plus c e to the 3x, and we're given the point 0, 2, so y is 2, so 2 equals negative 1 over 2 e to the 0 plus c times e to the 0, so 2 is equal to negative 1 over 2 plus c, so c is equal to 5 over 2, and now if we write out the entire equation, we get, let me just write a line here, y is equal to negative 1 over 2 e to the x plus 5 over 2 e to the 3x, and this is our final answer. Question 3, we have x dy over dx plus y is equal to x cosine of x. So one thing we have to see here is that there's actually a multiplier to dy over dx, so we have to get rid of that, and to do that we're going to divide the entire equation by x, so we just get dy over dx plus 1 over x y is equal to cosine x, and now dy over dx is by itself, and now p of x is equal to 1 over x, and I of x is equal to e to the integral of 1 over x dx, and this is just e to the ln x, and e to the ln x is just x. Now we're going to multiply x by all the terms here. So this is just going to be x dy over dx plus y equals x cosine of x, and then now let's write over here. So this is gonna, the left hand side is gonna be the derivative of y times the integrating factor, which is just x, and then the right side is x cosine x, and we're gonna integrate both sides. So this is gonna be yx is equal to, this is integration by parts, so let's do over here, let's use the table method. Okay, so our right hand side is going to be, and then this is plus c, so x sine x plus cosine x plus c. Now we just have to divide x by both sides to solve for y. So y is equal to sine x plus cosine x over x plus c over x. And since we're not given a point, we don't need to find a particular solution. So we just have y is equal to sine x plus cosine x over x plus c over x. And this is our final answer.